Okay, we're going to work on graphing exponential functions today. So this is going to be your homework, but I want to do a couple of them with you so that you can get an idea of what I'm looking for. All right, so we've been introduced to exponential functions. The equation for them is y equals a times b to the x minus h plus k. All right, we'll come back to that equation a little bit later and talk more specifically about especially what k does, and then we'll get into the other variables too. Okay, so let's do number 3 as an example. So when we worked in Desmos and graphed some equations that were exponential, one of two things happened. Either you were increasing or it was decreasing. So we're going to go through, find some points, and then we'll determine whether this gives us an increasing function or a decreasing function, and then why that happens. So I'm going to start with positive 2, and then I'm just going to work my way down, and we'll do a few points. So calculating a 2. So literally all I'm going to do is put in a 2 for the x, for the exponent. So then when I do 1/3 squared, well, what happens is 1 gets squared and then 3 gets squared. So this turns into 1 squared is 1, 3 squared is 9. So this is 2 ninths. So first ordered pair is 2 and then 2 ninths. Okay, the next one I'm going to do 1. So y equals 2 times 1/3 to the first power. So 1/3 to the first power is just 1/3. So 2 times 1/3 is 2/3. So then 1 and 2/3. Okay, so now let's do 0. So if I put in 0, it's going to be 2 times 1/3 to the 0 power. Well, anything to the 0 power is 1, and then times 2 would be 2. So we'd have the ordered pair 0, 2. Negative 1, if I put in a negative 1, so remember a negative exponent does the reciprocal. So the reciprocal of 1/3 is 3. So this is actually 3 to the first power. So 2 times 3 would be 6. So this would be the point -1, 6. Okay, let's do another point, and we're going to do -2 this time. So y equals 2 times 1/3 to the -2. Okay, so -2, again do the reciprocal, so this becomes 3 squared. So this would be 2 times 9, so 18. So we'd have the ordered pair -2, 18. Okay, you can get other points if you like, but this will be enough for us to tell what's going on. So -2, 18, -1, 6, 0, 2, 1 is 2/3, and 2 is 2 ninths. So you're just going to have to estimate those. But what you can see is this is going to be decreasing. Comes down pretty steeply. Looks something like that. Okay, let's talk about domain and range. Domain is going to be all real numbers, and that's going to be true of all exponential functions. Okay, not just this one. So every single one, domain, all real numbers. The range is based on the asymptote. So if you look at this, you can tell that this graph is going to turn and almost graphs horizontally as you go to the right. You're going to keep getting smaller and smaller decimals. So if you go back up here to 1, 1 is 2/3 or 0.6 repeating. 2 is 2 ninths or 0.2 repeating. If I increase my x's 3, 4, 5, I'm just going to get smaller and smaller decimal values, but they are never going to reach 0. So your asymptote is going to be at 0, and that makes your range real numbers greater than or equal to, not equal to, sorry, just greater than 0, because I never touch 0. That's where that kind of invisible fence is that we're not going to cross. Okay, the reason this was a decreasing is because of the 1/3. Okay, so if your value is smaller than 1, between 0 and 1, it's going to be decreasing. If it's larger than 1, it's going to be increasing. Okay, then the other thing is, what is your K? And your K is what's tagged on the end. So in this case, our K is 0. We didn't have a number added or subtracted to the end of the equation, and that tells you where your asymptote is. Okay, let's do one more together. We'll do number 5. Okay, so for this one, I can tell this is going to be an increasing function because my 4 is greater than 1. So I'm going to be increasing, and my K is -2. So when I go to find points, my asymptote is going to be at y equals -2. So this is where that invisible fence is going to be that I'm not going to be able to cross. Okay, so if we start with, we can start with +2, and then again, I'm just finding my points. It doesn't matter to me whether you work in fractions or if you use a calculator to find your points, that's fine, as long as you know how to correctly put in the equation to do that. So decimals are fine, fractions are fine, either way. Okay, I'm also going to do 1, so 4 to the first minus 2, well that's going to be 4 minus 2, or 2, so 1 is 2, and then if I do 0, 4 to the 0 is 1, anything to 0 power is 1, so that's going to give me 1 minus 2, or -1, so 0, -1, and then let's do -1 and -2. So put in a -1, so 4 to the -1st power, and then -2. So again, negative exponent, do the reciprocal, so that's going to make this 1/4 to the 1st power, so that's just 1/4 minus 2. That's going to be a -1 and 3/4. So you're going to have the ordered pair -1 and -1 and 3/4. And then last, let's do -2. So y equals 4 to the -2nd power. Okay, so reciprocal again, 1/4, and that's going to get squared. So that's going to be 1/16. So 1 squared over 4 squared, -1 and 15/16. So -2 is a -1 and 15/16. So you can see just by going to -2 how close that's our values trying to reach -2. So we are just barely above -2. And then -1 is -1 and 3/4, 0, -1, 1, 2, and then 2 jumps up to 14. So again, when it increases, it's going to increase very steeply. Okay, so again, domain's going to be all real numbers no matter what. So for every one of these graphs, domain is all real numbers. Range, look at where your asymptote is. It's -2, so it's going to be real numbers greater than -2, because there's your fence that you can't cross. Okay, so this one was an increasing exponential. The one we did previously was a decreasing. So let's just go back to the beginning, and we're going to run through. On number 1, it's going to be increasing, because it's a 3. 3 is bigger than 1, so you're going to increase. You also, your K is 0, so that means your asymptote's going to be at 0, y equals 0. Okay. Number 2, you're decreasing, because 1/3 is less than 1. So you're going to be decreasing on this one. And again, your k is 0, so asymptote y equals 0. Okay, number 4. Again, k is 0, so asymptote's going to be 0. And this one is going to be increasing. Now on this one you have the 5 times the 2 to the x. It's the 2 that you're looking at. It's called a growth factor. We'll talk more about that after spring break. But it's the number that has the exponent on it. That's the number that's going to determine whether or not you're increasing or decreasing. So this one's increasing. And then number 6, also increasing because of the 4. 4 is bigger than 1. And my k is 1. So this one, my asymptote's going to be at 1. And you can sketch in that asymptote so you already know where that fence is. And then 7 and 8. So number 7, asymptote's at 2. Again, because k is 2. And this one's going to be decreasing because the growth factor is 1/2. So decreasing, it's coming down. Okay, last one, number 8, my k is -1. So my asymptote's going to be -1. And then what has the variable? The 2. So we're going to be increasing on with that 2. So my graph is going to be increasing. Okay, so finish graphing those. Again, you can use your calculator if you want to find points. You can use your calculator to find points if that's helpful, or you can just do it by hand like I did.